In our second unit, we'll be talking with you about evaluating. And another word for evaluating, another math word for evaluating is simplifying. And another non-math word, but a word that math teachers and people like to use quite frequently, is plugging in. That's another word to describe evaluating. So we're going to go through the process of evaluating. And we have three sections that we'll be going over under the umbrella of evaluating. First, we'll begin with just showing you the action of plugging in or substituting. And we have some examples with that. Then we have some more applied problems. The Accuplacer likes to put you in situations where you convert from, let's say Celsius to Fahrenheit or Fahrenheit to Kelvin or inches to feet or whatever the case may be. So we have some word problems where we'll be doing some substitution as well as careful reading. And then last but not least, we're going to go through probably the most important test-taking strategy that you will utilize on pretty much every single question that you encounter on your Accuplacer. And we'll show how you can use evaluating to verify that you have the correct answer every time before you actually hit submit when you're taking your test. So it's going to be the last thing you do before you hit submit every single time, and we'll show you some crafty. It's a really crafty test-taking technique, and we look forward to showing you that. Okay, let's go for it. All right, so the first skill that we're going to talk about is the act of evaluating or plugging in or substituting. And so commonly you'll see problems like this on the Accuplacer where they give you a value for A and a value for B, and they ask you to plug in or substitute. Everywhere there's an A, you'll put a 4. Everywhere there's a B, you'll put a -3. So this is evaluating. You must always use parentheses when you are plugging in or substituting. I almost think of this like Mad Libs. Like when you're reading a story and you say, he is a very, and then it has, a line and it says adjective underneath. And then you have to fill in a word for that adjective in place of the adjective. Well, there's a similar phenomenon happening here. In place of A, you're going to substitute or fill in its place a 4. So let's consider, if we consider A minus B over B, well, in place of A, we're going to substitute the number 4. In place of B, we're going to substitute the number -3. And in the denominator, we're going to put another B down there. So we have A, which is 4, minus sign, B, which is -3. Notice the use of parentheses on all of these, divided by B. And B is -3. So what we're doing in place of A is substituting in 4, B substituting in -3, and we're going to see what sort of numerical value we have here. So hence that name, evaluating. You can actually hear the word value in there. So we'll get just a number in the end, all right? So now what we can do, especially since you by now have watched the first video carefully, you should know how to handle this. Well, if we have a -3, that's going to turn into a +3. That's like distributing, or that's like multiplying -1 times -1 times -3. That'll make a +3. Okay, so now we're just going to kind of clean this up. So our numerator is 7, and our denominator is -3. So there you go. When A is 4 and B is -3, the expression A minus B over B is equal to -7/3. And all we did was we plugged in or we substituted. We evaluated. Okay, so now let's try this next example. And again, it's a key reminder here to use parentheses. It's it's very, very important for you to do that. Okay, so now in this next example, we'll do the same thing. Okay, they've given us values for a and b. They say a is -3 and b is -4. And we're going to plug into this different expression here. So I might even set myself up with my parentheses before I do anything else. I strongly recommend you do that. Whatever goes here will be a placeholder for a, plus whatever goes here will be a placeholder for b, a minus whatever is in place of b. Okay, so now we can plug in or evaluate. A in place of a is a -3 because a is the exact same thing as -3. B is the exact same thing as -4. A is the exact same thing as -3, and B is the exact same thing as -4. So you see how we've evaluated or plugged in or substituted numbers or values in place of A and B. All right, so let's clean up our numerator. -3 plus -4, well, a negative plus something that's negative as well is going to make even a bigger negative. It's like if I owed you $3 for a soda and $4 for a sandwich. I owe you $7, and I'm using the negative symbol to represent debt. We could probably check out my bank account and see some debt there as well. Okay, now you got to be careful in the denominator here, because we have this minus a -4. That's going to change the sign into a +4, just as it did in this earlier example. So we have the -3 just kind of hanging out. -4 is the same thing as +4. Okay? And cleaning this up, we have a -7 still in the numerator, or in the top of the fraction. Down low in the denominator, we have a -3 plus a 4. Now keep in mind the 4 is positive, and the 3 is negative. So if I asked you, what is 4 minus 3, that's equivalent to this expression right here. See how the 4 is positive, and the 3 is negative? Well, what's 4 minus 3? That's just 1. Cool. And what's -7 divided by 1? That's just -7. So we have successfully evaluated or plugged in or substituted in a couple of situations here. And this skill is so important in any math that you get into, but especially on the Accuplacer. This action of substituting or plugging in and using parentheses as you do it is of the utmost importance. So here we have a couple more examples of plugging in or substituting, otherwise known as evaluating. And remember, every time we put a number in place of a variable, we're going to use parentheses. It's a great habit to get into. All right, so if x is 2, then x plus 5 divided by x minus 5 equals, well, I know that in place of x, I'm going to be substituting 2 in. So I kind of have the general structure right here, but in place of x, it's almost like there'd be a substitute teacher. 2 will be in place of x there, and 2 will be in place of x there. Okay, now let's focus on the numerator. 2 plus 5 is 7. The denominator, 2 minus 5 is -3. And that's our final answer, -7/3. Okay, so again, all we did was plug in place of x. Everywhere there was an x, we put a 2. And then we cleaned things up and we got a value or a number in the end. So this next example is very important, because notice how in the previous example, everywhere there was an x, there was 2 spots where there was an x. We had to substitute a value or a number in. Well, same thing here. We're going to look at this expression, and everywhere there's an x, we're going to plug in a -1, and we're going to be very careful to use parentheses. And we're going to have a little bit of deja vu. We're going to kind of have a throwback to Unit 1 as we go through this one. Okay, so I might think about how this expression looks in general. Notice how I use parentheses. Everywhere there was an x, I knew I was going to be substituting the value -1 there, so I kind of set myself up for success. In place of this first x that's squared will be a -1, and in place of this second x will also be a -1. So I just plugged in, I substituted in place of x, I put a -1. Okay, now all of our work with PEMDAS should help make this go smoothly. In terms of parentheses, exponents, multiplication, division, addition, subtraction, what should happen next is this exponent, and I strongly recommend you expand this out. -1 squared, well, see how it's all in parentheses there? We know that the entire thing, meaning -1, is multiplied by itself. Okay? Notice how I'm always taking the time to rewrite everything. If you start to miss things, you might skip things and then forget about them or not interact with them correctly. So just be careful. Okay, so we understand how to expand an exponent. Now a negative times a negative is a positive. 1 times 1 is 1. Okay, so we've cleaned that up. That's multiplication. Here we also have multiplication. -3 is standing right next to, otherwise known as multiplied by -1. That'll make a +3. And we have a -2 here. So notice, PEMDAS-wise here, we had some multiplication. We did some multiplication left to right. We would not do the subtraction by 2 first, because that's lower in the order of operations, or the way in which we simplify. Okay, now we can just go, from left to right. 1 plus 3 is 4, and 4 minus 2 makes 2. So we successfully evaluated or substituted or plugged in when x is -1. We know the value of this expression is the number 2. All right, so this concludes the first of the 3 skills from this video. Our second skill of this video, as aforementioned, is using evaluation to interact with and make sense of word problems. So I made up some things that are not real. A nuson and a quarson do not exist, but I made them up. And, it's possible on the exam they might give you something that you've never heard of. But in the end, we're still going to be able to interact with it successfully and evaluate successfully. So, Martians have different ways of measuring temperature. They've got musons and quarsons. Nusons can be converted to quarsons by the following equation. So even if you didn't read any of that, which you should, just to familiarize yourself, this equation is of the utmost importance. All right, Q equals N plus 152. Now, don't let it throw you that you're dealing with Q's and N's. You can deal with A's and B's, or X's and Y's, or Q's and N's, or K's and C's, or C's and F's, and it doesn't matter. You're still going to be just fine. All right, so now they want to know the nuson equivalent, and we know nuson, N stands for nuson. The nuson equivalent for 30 degrees quarson. And so that is the equivalent of saying Q equals 30. So, if Q is 30, what is N? That's really what they're asking. So now all we're going to do is plug in. In place of Q, right here, we'll substitute in a 30, and then we're going to figure out what N is. In place of Q, we have a 30. Okay, and to be honest, these parentheses don't really serve a purpose in this situation, because 30 is just 30. But I will take the time to rewrite it. Okay? There wasn't any multiplication or squaring or anything we had to do here, so things are just kind of as is. So now what we're going to do is we're going to solve for the missing number N. And we will be going over solving. I'll be doing that in unit number 5. This should feel like a blast from the past, and if you're not okay with this, you will be okay with this soon. If you are okay with this, we're just gonna go for it. But for now, even just getting to this point, taking a tremendous word problem, bunch of sentences, bunch of words, and converting it, deciphering the important math and substituting is really in the spirit of this video. Solving, we'll learn more about it later, but for now, I'm going to subtract 152 from both sides because I kind of want to get N alone so that I can solve for N. And I know that positive 152 and negative 152, when you put those two things together, you get 0, so that disappears. So I just have N by itself. And then if we look over here, 30 minus 152, that's certainly going to be negative. That should be negative 122. So what does this mean? That means that 30 degrees Quercen are the same thing as negative 122 degrees Newson on Mars. And again, I made this all up, but you never know what situation they're going to throw you into, and the most important thing is to just decipher what they're telling you, what equals what equation you're interacting with, and what are you trying to find. We were trying to find Newson, which is n, and we found it out. Okay? So converting from one situation to another situation by way of evaluating is a very, very important skill. And so now I have the same sort of problem. We have the same equation here. And the big thing that's different is now they're asking us for the Quercen equivalent. In the first example, they asked us kind of what was n. In the second example, if they say what is the Quercen equivalent, that's like saying, well, what is Q? Notice here, they're telling us that n is negative 173. So same equation, we're just given a different piece of the puzzle. We have this equation right here, and in place of n, we're going to substitute negative 173 because n is equal to or is the exact same as negative 173. So we don't know what Q is, but in place of n, we're going to put negative 173. Okay, so notice how we just have numbers here. They're being added. When you're adding or subtracting things, you're going to combine like terms. So if you have negative 173 plus 152, that's going to make negative 21. That means that negative 21 degrees Quercen are exactly the same as negative 173 degrees Newson. So notice how we kind of worked this equation one way, and then we worked it the other way, or backwards, if you will. We were given Q in one situation, we were given N in another, and this is all still just evaluating or plugging in. And notice how we're reinforcing the skills, we're repeating the skills of plugging in using parentheses and then thinking about things like combining like terms and just being really careful with your simplification. So now we come to the third and final skill of the evaluating video. And this skill is so important. You're going to use this on every single problem, and it's going to be the last thing you do before you submit your answer, just so that you know before you hit submit that you definitely got it right. All right? So what's cool is I took some problems. There's a problem on this slide, there's a problem on the next slide. I took some problems that you will eventually know how to do in their own right, know how to do mathematically. But what I'm going to do is just kind of show you a test-taking technique. So once you think you have the right answer, you can kind of use this technique to actually verify 99 times out of 100 that you are correct. All right, so what we're going to do here is before you submit any answer, you're going to verify that your answer is correct. How are you going to do that? Well, notice I see a bunch of expressions here. These are like a bunch of things with terms and symbols just kind of floating in space or in the ether. So what we're going to do is we're going to pick a value. All right. So you can't just pick any value. There's certain values that won't be very good. I recommend that you never pick -1, 0, or 1. They're just kind of weird, special values. I also recommend you don't pick anything that when you plug in, you get, let's say, 0. So if you look, we haven't talked about factoring. We have a bunch of answer choices here. We want to know which one is equivalent to this initial expression. Well, what we're going to do is we're just going to pick a value. And if I look at the answer choices, I notice that things like 1 and -1 and 4 or negative 4. If I plugged in a negative 4 there, I'd get 0, and 0 times anything is 0. I'm not going to pick any of those numbers. So I'm gonna let x equal 3. And so what's interesting is the way I'm going to show this to you, this test-taking technique will work even if you don't know how to factor. You will get this answer correct 99 times out of 100. We do want you to be reviewing and learning the math, but also this technique is very strong in its own right, but again, you're going to do it at the end of every problem before you hit submit. Okay, so in every single one of these situations, we're going to look at the initial problem. We'll plug in 3. We'll see what that value is. And then we're going to plug in 3 into each one of these expressions. And now, in order for them to be equivalent or the same, whatever value we get when we plug in 3 here better be the exact same value that we get when we plug in 3 into the answer. So it's kind of like a sneaky, crafty way to go about things. So remember, we're going to use our parentheses, and let's plug in, everywhere there's an x, we'll plug in a 3. So notice how I kind of set myself up. Something squared minus 3 times something minus 4. Now I'm going to make x be 3. And when I clean this up, PEMDAS says exponents first, 3 squared is 9, minus 9 minus 4. That's going to equal negative 4. So I know that in the equation that I'm starting with, when x is 3, and I plug it in, and I evaluate it, I should get out a negative 4 when I plug in that 3. So each one of these answers, in order for them to be equivalent, they might look different, which they do. They're all in factored form. But if I plug in a 3 into any of these expressions, if they are equivalent to the one that I'm given, I should get the exact same value. So I should get a negative 4. And I know I kind of did this calculation quick, but I think you're with me on that. All right? So now let's just plug in, everywhere there's an x, a 3, into each of the answers. All right, so here's an x. We'll plug in a 3 for x. And we'll plug a 3 in for x. And I'm going to do this in one fell swoop. Okay? So I'm just going to set myself up. And notice how these terms are standing right next to each other, so they're multiplied, 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 and multiplied. Okay, so everywhere there's an x, I'm going to plug in a 3 into every one of these situations. Everywhere there's an x, I'll plug in a 3. Everywhere there's an x, I'll plug in a 3. And now 99 times out of 100, or I really like 999 times out of 1,000, whichever answer down here, when we evaluate it, when we plug in 3, yields a negative 4, will be equal to and the same as this initial expression. So now let's clean them up. The first one, PEMDAS, we're going to focus on the parentheses. Inside this parentheses, we get a 7. And then inside the next set of parentheses, we get a 4. 7 times 4 is 28. Well, when x is 3, we know we should be getting out a negative 4 when we plug in 3 into the original. But when we plug in a 3 here, we get 28. That means this answer choice is out. All right, let's keep trying. Here we have 3 plus 4, that'll make 7. PEMDAS says to focus on those parentheses. And 3 minus 1 is 2. And 7 times 4 is 14. But we wanted a negative 4. So this answer choice is out. Let's check this guy right here. We'll go in order. So 3 minus 4 in parentheses. 3 minus 4 is negative 1. And 3 plus 1, that makes 4. And what's 4 times negative 1? Negative 4. So that's kind of cool. In the initial expression, when we plug in 3, we get negative 4. In this expression, which certainly looks different than the original, when we plug in 3, we get a negative 4. Huh. That must mean that this is the correct answer. But let's just go so far as to check the last one. 3 minus 4, that's negative 1. 3 minus 1, that's 2. That makes negative 2. It should have made negative 4, so it's definitely not correct. So I'm feeling pretty darn confident that even though I might not know how to factor this, I could actually figure out which expression was equivalent to the initial expression. And sure, this took a good, 4 or 5 minutes, but that's okay. You have infinity time on the Accuplacer, and before you hit submit on any problem, you need to plug in and check to verify your work so that you know you're getting every single question right. So here is another challenging question that you will learn how to do by the end of this, by the end of unit 4. But what's kind of cool is we can still actually get the right answer by just evaluating or plugging in, a thoughtful value. Because whatever we plug in here, and get, better be the same as, let's say we chose to plug in a number here. I'm going to make it up like 20. If I plug in 20 here, and whichever one's the right answer, if I plug in 20 into that, I better get the same value, otherwise they're not equivalent. So we're going to use that same idea that we used in the last example. And if I look at this original problem, I can kind of see if I plug in, I've already recommended you don't plug in negative 1, 0, or 1. If I plug in a 0 there, I'd be dividing by 0. That's going to be a little weird. Definitely don't plug in 0. I'm going to recommend you don't plug in 4 as well, because 4 minus 4 is 0. And remember, I recommended you don't plug in things where you're going to, let's say, make 0 on a factor, and you don't want to divide by 0. So I'm going to pick my favorite number again. I'm going to let x equal 3. And that's actually not my favorite number, but for this demo it is. Okay, so now we're going to look at the expression we're given, and everywhere there's an x, I'm going to plug in a 3. In place of x, I'll plug in a 3. In place of x, I'll plug in a 3. Okay, and so I have 1/3 plus, 3 minus 4, that's negative 1. That's going to be a third. And then 1 divided by negative 1 is just negative 1. So a third minus 1. Now, we will be going over fractions more, but I want to, we will spend a fair amount of time on that. But so whatever expression, one of these ugly 4 expressions, whatever one's equivalent to the original problem, when I plug a 3 into it, I better get a third minus 1. And I don't want to get into fractions too much yet, but I will tell you, a third minus 1, that's going to be a number that's negative, meaning that it's going to be less than 0, and it's not going to be as big as negative 1. I could simplify this fraction, but let's not, and let's just see if we can kind of weed out some of the answers. Now remember, we're going to go over this mathematics in the future, but I just want you to be sure that even when we've reviewed, you feel more confident on fractions, you're going to do the math, but then you're also going to engage in this answer verification. You're going to plug in a number and make sure that the answer choice that you think is right is in fact right. All right, so now let's try each of the answer choices. Everywhere there's an x, let's plug in a 3. And we're going to evaluate. Everywhere there's an x, plug in a 3. Everywhere there's an x, plug in a 3. So I could be telling you a joke right now. You know what I mean? I don't even really have to think that carefully. Just as long as I focus on my parentheses, everywhere there's an x, I'm plugging in a 3. Same thing. Okay, and then this last guy, everywhere there's an x, I'm plugging in a 3. What I want to do, and maybe I don't even, let's say I don't even know how to do this problem, let's say. I will at least be able to figure out that some of the answers are wrong. And have a better chance of getting the answer correct. And in the denominator here, everywhere there's an x, plug in a 3. All right. So now, let's work from the bottom up. Okay, so in the numerator here, we'll do our multiplication first, because PEMDAS says multiplication before subtraction. 2 times 3 is 6. 6 minus 4 is 2. That's our numerator. Okay, in our denominator, PEMDAS says exponents first, and then we'll do multiplication, and then we'll do subtraction. 3 squared is 9, and then minus 12. 9 minus 12, okay. 9 minus 12 is negative 3. All right. So this answer is negative 2/3. Okay. So what's cool is I know this answer is less than 0. This answer is less than 0, so it's still in the running. But if you look at this answer, I have 2 over 3 squared minus 12. 3 squared is 9 minus 12. 9 minus 12, that's going to be a negative 3. Oh, okay. And on our second example here, we have 1 over, that'll be 9 minus 12. We know that's negative 3. Okay. In our first example, we have 2 over 3 minus 4. 3 minus 4 is negative 1. So, in order to whittle these down, I know I can kind of safely say that this answer's out. 1/3 minus 1. To be honest, that equals negative 2/3. And we'll go over that soon. But even if you didn't know that, you could say that that number is less than 0, but it's not less than negative 1. So this answer choice where we get a negative 2, we'll have to cross that out because that's these two, that must mean these two expressions are not equivalent. Because whenever I plug in a number here, and I plug in that same number into my answer, I should always get the same value out in order for them to be equal, or in order for them to be equivalent. So this one is a little too big. We should have had negative 2/3. So what's interesting is we don't actually have an answer yet. It's kind of funky. We have two things that make negative 2/3, and so does the initial expression that we were looking at. So what does that mean? Does that mean that there's two right answers? No, well, really what that means is you're going to have to plug in another x value. So we're going to have to plug in another x value here, and we're going to have to plug in another x value here and here. Plug in that same one, and hopefully we'll have different values here, but one of these will have the same value as our original, and then those two things will be equivalent. So I'm going to do this kind of quickly, but let's say I'm going to let x equal 5. In the original problem, okay, I'll have 1/5 plus 1 over 5 minus 4. That's 1/5 plus 1 divided by 1. So when I plug in 5, I have a 5th plus 1. That's a number that's slightly larger than 1. I'm hoping that one of these two candidates will have a number slightly larger than 1, so then I will know that that is the winner. So if I were to go to this expression and plug in a 5, I'd have 2 over 5 squared minus 4 times 5. That's going to be 2 over 5. All right, well, notice this number should be equivalent to this number, but 2/5 is way smaller than 1 plus a 5th. So this answer is out, because we did not have the same value. And just to show you that this does work, let's take our 5 and let's plug it into this bottom expression. I'd have 2 times 5 minus 4, notice the use of parentheses, over 5 squared minus 4 times 5. Well, what does that make? Well, in the numerator we have 2 times 5, multiplication first, that will be 10. 10 minus 4 is 6. And our denominator, 5 squared minus 4 times 5, that will be 5. 6/5 is bigger than 1. It actually is the same thing as 1 plus a fifth. So this really kind of shows you this number is the same as that number. They're both bigger than 1, and they're actually equivalent. Again, we'll do more with fractions later. But you can kind of see how even if we didn't know how to add or subtract fractions, just by evaluating and persevering, we found out the right answer. So remember to use this test-taking technique of answer verification. Take a number, plug it in, evaluate it in the expression you're given, and evaluate it in every single answer choice. Only one answer choice should have the same value as the initial expression. Those two are equivalent, and you've got your answer correct. Okay? Good job.